Okay, welcome back. In the last week, at the very end, we show you with the example, right? If you still remember, we have a relation for the FSU students, as shown here in this page. And we have a FSU ID, name, department, and a chair as the attributes for the relation. And based on this relation, we can find some FDs, the function dependencies. The first FD we can find is FSU ID can imply name, department, chair. We can say this FD is very good because based on the FSU ID we can imply all the other attributes in the relation. And according to the definition of keys, so we can find this FSU ID is a super key first, right? And also we cannot find any subset of it can also imply all the attributes. So based on these 2 points, we can conclude that the FSU ID is a key for the relation, right? I hope you will remember the definition of keys. They have 2 conditions. The first one is it can imply all the attributes. The second one is none of its subset can imply all the other attributes. So both of these 2 conditions are very important to find the keys, right? Besides this very good FD, we can also find another FD which is shown at the bottom. Department implies chair. This FD is correct, right? Because given a department, we can find one single chair of the department. However, we can say this FD is very bad because this FD, in this FD, we have department as the head, we have the chair as the tail. However, none of these 2 attributes are the keys or the super keys of the relation. We can say this FD is very bad because this FD can introduce not so redundancy in the current relation, right? Because we know given the department, we will know its chair by default. Then why we need to include the chair in this relation? We don't need to do so, right? Because they will introduce not so redundancy information in the relation. So in other words, based on the FDs we can find in a relation, we can find some problems about the relation design, right? For example, in this page, we find this chair, this attribute should not be included in this current relation, and it should be removed because they can imply by the departments. So based on this idea, we need to introduce some scenario to help us to further polish the relation that we have. And a scenario we can use to help us to refine and polish the relations is called the normal forms. We can also say the normal form as NF for short. So normally when we do the relation schema refinement, we have some desired properties for the target relations. The first property is to minimize the redundancy. Because the redundancy is not good, if we have redundancy in a relation, we may have lots of problems, as we mentioned before, right? Especially if we plan to edit or update or delete some of the information in the relation. If we have redundancy, then we may miss some of the information editing or some of the deletions. And we should also need to avoid the information loss. If we refine a relation, we should avoid the information loss after the refinement in the new relations, right? In addition, we also plan to preserve the dependency we can find in the original relations for the new relations. After we do the refinement and the polishing, we hope we can still preserve all the original dependencies. The next one is to ensure very good query performance. Because if we do the refinement of the relations, we may have to divide a relation into several small-sized relations. In other words, a relation will be divided into several fragments. If we plan to do some queries on the original relation, after we do the refinement, then we may have to use the joins to help us, right? According to the previous section, we know the join is based on some very complex and expensive operations, like the product. So therefore, they may introduce not so query time cost if we do very heavy refinements. Normally, in the refinements, we have some trade-offs in the polish of the relations. So to achieve these 4 desired properties, we need to have the normal forms to help us. So we have different kinds of normal forms proposed already. from the first normal form, the second normal form, BC normal form, third normal form, fourth normal form, and etc. So we have different normal forms. You may wonder which one we should learn or we should use for our relation refinements. Different normal forms can achieve different desired properties as shown here. So we need to have a trade-off among these properties. Depending on our requirements, we need to balance or trade off among these properties and to decide which normal form can be used for the schema refinements. The first normal form we propose by the academia is called the first normal form. In this normal form, we divide all the relations into attributes, and all the attributes are atomic. And we also have a second normal form, and this one is also very old, and we don't use it very often now. The most important one we will cover in the lecture is called BC normal form, or the boys called normal form. In the near future, if you plan to find a job and when you do the interviews and people ask you knowledge about database systems, they will ask you about BC normal form. What is BC normal form and how to polish a relation into BC normal form? They are frequently asked questions about database systems. Another normal form we introduced in the lecture is called third normal form. It is also very important. Compared with the BC normal form, third normal form provides more relaxations. So all these normal forms can achieve different properties as seen above, and they also provide different trade-offs among the properties. We will cover them in the lectures with a special focus on the BC normal form and third normal form.